talk about ratios and proportions. So you're wondering to yourselves, what is a ratio?
Wasn't actually, but go ahead.
But now you are. You probably have learned about ratios. So we're going to throw a geometric spin on it. So a ratio is a comparison of two or more quantities. We've got three ways in which we can represent a ratio. So the first way is a fraction. Probably the most common way you guys have seen it, just A over B. The second way is in word form, like word, homie. So A to B. And our last way we can express a ratio is in analogy form, which is just A colon B. So analogies are also in English, right? What's an analogy in English? Come on, your English teachers are listening. Right. When we compare two more things, like we can just say, hey, cat is the kitten, his dog is the puppy. Boom, look at that. Extra bonus points from the English teachers. I probably can't authorize that transaction, I'm sorry. And last thing is ratios can and should be simplified. If it's not reduced, it's not necessarily wrong. It's just not the most right. Oh. Oh. I mean, it's not wrong. It's just not as right as it should be. Well, we're all different. God made us all different. Some people like to take points off for that. Some people like to mess with you and say they're going to take points off for not having a bar above your segments.
He said. He didn't. He told us that he was doing this so that we be compared to high school, but he turned out to be harder.
Well, that's what our jobs as teachers is. We just try to scare you with how dangerous the next place is. So you're like, oh my gosh, I got to be ready. And then it's always easier. And when was the last time you wrote cursive?
I feel like this class is, I feel like this work, I feel
Signature.
like this class is probably more work in algebra, but in algebra, there's a lot of smaller problems that are like, there's a ton of them now.
Yes.
So like there'll be like 10 hard problems versus 30 easy problems.
Right. That's the way I like to do it. Yeah. So for our first example, a music store has got 40 trumpets, 39 clarinets, 24 violins, 51 flutes, and 16 trombones. Write each ratio in simplest form. Let's go ahead and add those guys up just because we may need a total later. You never know. So we got 40 trumpets, 39 clarinets, 24 violins, 51 flutes, and 16 trombones. When I put those together, what do I get? What is the total? 40 plus 39 is 79, plus 24 is 113, 51 is 154, and then 16, 180. Sounds great. Except for it's 170. It is. 40 plus 39 plus 24. Yep, I'm sorry. Plus 51 plus 16 is 170. So there's 170 total instruments in our music store. So let's see what ratios they want us to set up. So we're just going to set them up as fractions because those are the easiest to simplify. So it says trumpets to violins. So we're going to set up a ratio that has trumpets on top and violins on bottom. How many trumpets are in the store total? 40. And how many violins in our store? 24. So is that number reduced? No. Can I reduce it? Yes. My calculator will actually reduce it for me, right?
I love my this.
Your calculator has the ability to reduce fractions. MathFrac. MathFrac is our friend. Okay. So we're just going to put our fraction right into the calculator. So 40 divided by 24. And when I pop that in there, oh no, it gives me a decimal. We don't want silly old decimals. So if we hit this math button, it's below your green one. It gives me all kinds of fun math things. So we got frac, dec, cube, cube root, unknown root, minimum of our function, maximum of our function, all that extra stuff. But right here is all I'm worried about. One frac. So we're just going to hit math, and then we're just going to select frac. Math, the green, right below the green button, and then we're going to hit frac. So when we hit math and then frac, it gives us this in our screen. Hit enter, and it tells me the fraction. It'll do it every time. Hooray, so our answer is 5/3. Guys, get used to using MathFrac. It will make your life easier, especially on these big old bad standardized tests. Yes, sir.
Okay, so does it matter how we write it, like for the fraction?
It doesn't matter because it didn't specify what it wanted, so I'm just going with fractions because fractions are the easiest to simplify. You could have wrote it in Word form. It's already in Word form, so we got to take it from one to another. So what about flutes to clarinets? So we got flutes on top, clarinets on the bottom. How many flutes were available to purchase? 51 flutes. How many clarinets? Make sure it reduces, or if it don't, or not. Does 51 over 39 reduce? MathFrac gives me no.
Maybe.
Well, let's see. So we go 51 divided by 39. And from here, I could even hit MathFrac from right here. I don't got to get the decimal first. If I just hit math and then frac, it'll take my fraction and turn it in and keep it as a fraction. 17/13. Who knows? All right, trombones to trumpets. So trombones to trumpets. How many trombones? 16. How many trumpets? 40. Reduce 16 over 42. They're both divisible by 8. 2 over 5. And our last one is violins to the total instruments. Oh, good thing we got that total earlier. Who could have ever expected that? I am shocked. So violins over total. How many total violins are they? 24. Over my 170 total instruments. Somebody MathFrac that rascal for me. 12 over, oh, Peter. 85. What? It is a decent little microphone.
Maybe it won't be there in the morning.
Wow.
If it's not here the next day.
So that is just our basic ratios. Now let's take a peek at some extended ratios. And an extended ratio is just a comparison. Instead of 2 or more, it's going to be 3 or more. Yay! So we can have 3 or more ratios. And then we write our extended ratios. You'll really only see them in analogy form. So A to B to C. So this is where we throw a little bit more algebra on top of our geometry. Everybody's favorite thing. So we're going to take our geometry knowledge, tie it up with some algebraic knowledge, and see if we can't figure out side and angle values given only a ratio. So number 1, our 5 says, the ratio of 2 complementary angles is 3 to 7. Find the measure of both angles. So first off, what is a complementary angle? What does it mean for angles to be complementary? Their sum is 90 degrees. So when I add these two together, it's going to be 90 degrees. So to set up this expression, I know I'm going to have 2 angles that when added together, they equal 90. Does anybody not agree with that? It's a great answer. So we've got to use the ratio given. And then we're going to use a placeholder that we use pretty much every day of our lives in math class. X. So we know the first angle will be 3 times x, because we know it's whatever it is, if whatever x value is, there's 3 of them. And we know the second one to be 7 times x, because whatever x is, there's 7 of them. No. So now we just created a linear algebraic expression. And we can just solve for x. So 3 plus 7 is 10. Because they're complementary, the sum will always be 90. So like on number 6, they said supplementary. So the what it equals might be different, but we just got to tap into our brilliant minds and coordinate what it needs to be. So 10 over x, divide both sides by 10. Oh no, she gone. Going for a ride, folks. So we got 10 divided into both sides. So x equals 9. It wants us to find the measure of both angles. So we take that value of x we just found and just plug it back into the angles we know. What is the value of our first angle as it exists right now before we substitute? 3x. And when I substitute x for 9, the first angle's measurement is 27. The second angle, as we know it, is currently 7x. When I substitute x for 9, the value of our second angle is 63. Now, because it's math, there's a couple of ways we can check ourselves. What's the first way? These two angles should add up to what? They should add up to 90. If we did it right, 27 plus 63 should be complementary. Is that true? 27 plus 63 is 90? Bingo. What's another way we can check ourselves? So we check that they're complementary. Let's check to see if the ratio exists. So let's check to make sure that that 2763 makes that same 3:7 ratio. So we create our fraction, 27 over 63. And we go back to our El Calculadora. Dora. We go 27 divided by 63. Math, we want frac. 3 over 7. So does our ratio match the required ratio? Absolument. So our answers are 27 and 63. Any questions? All right, let's look at number 7. The ratio of the measures of an angles in a triangle is 4 to 7 to 9. Find the value of our angles. Find the measurement. So what do we know is true this time? Using our little bit of geometry. These 3 angles, when added together, need to equal what? Why? It's the inside of a triangle. No matter what, the inside of a triangle will always equal 180 degrees. That's our triangle sum theorem. So our first angle is what? 4x. Second angle, 7x. Third angle, 9x. What is the outside of a triangle? The outside of a triangle would always be its perimeter. There is no set value because the outside of a triangle can have different side lengths. But no matter what the side lengths, the inside will always be 180. So we're going to add our like terms. 4 plus 7 plus 9. Is that 20? 4 and 7 is 11. 11 and 9 is 20. Equals 180 degrees. Divide both sides by 20. So x is 10. No? 9. Good. Now we take our value we found and we just substitute it. So 4x is really 4 times 9, which is 36. 7x would be 7 times 9. I like how they just gave you all the same problem back to back. 63. And then lastly, the last one is 9. So 9x equals 9 times 9, which is 81. Oh gosh. 9 times 9 is 81. And if I really wanted to check my ratio, all numbers are divisible by 9. And it would just bring us right back to the front. So you had a little bit of foreshadowing in your question. Well, what if they want us to find side measures? Well, for a side measure, they have to give us the perimeter because we don't know how to find side lengths yet. We'll learn it. We'll get there. But we ain't there yet. So for the ratio of the measures of the sides of a triangle is 2, 8 to 9. The perimeter is 76. Find the length of each side. So like we talked about, there is no exact length that the outsides will always add up to. They're going to have to give us something. Usually it's going to be the perimeter. or they could give us an area where we just have to set it up a little different. But for the sake of today, they're going to give us a perimeter. So we know that those three sides, when added together, their sum will be 76. We just don't know the value of each side yet. But we are strong, we are smart, and we are capable, and we can find them. So what are my three side values going to be? 2x, 8x, and 9x. Put them together, what do we get? Bibbidi bobbidi boo. 19x. Divide both sides by 19. Why do I do that? Why do I do that to myself? You're already in red. Why would you switch the color, dummy? So x is 4. And then to find our side lengths, we're just going to substitute 4. So 2x is really 2 times 4. 8x is really 8 times 4. And 9x is really 9 times 4. So what's our first side length? 8. Second side length? 32. And our last side length is 36. Magic. Go ahead.
I got it.
You got it? Making sure I didn't mess something up. Y'all got to keep me on check now. What is a proportion? Well, a proportion is just an equation that sets two ratios equal to one another. What's a ratio? Comparison of two numbers or more. So an equation takes those ratios, the comparison of two numbers, and just sets them equal to one another. So we'd write our proportion as A over B equals C over D. So whatever the ratio is, we just pop them equal to each other. And then we're going to use the cross product property to solve for X. Let me zoom in a little bit. I don't want y'all to squint back there. Damage your little pupils. I damage the pupils of my pupils.
Maybe it's your dad joke.
Probably. I love the dad joke.
Why aren't you supposed to be fractions?
Sure. We are doing ratios, so
Like
fractions could
long-
exist.
Like long decimals.
I probably don't want decimals, but there could be decimals. Decimals could exist, or it could ask for fractions.
In
But the instructions, yeah, it depends on what the instructions ask for. If it asks for a fraction, then give it a fraction. If it asks for a decimal, give it a decimal. If it asks you to round to 2 decimal places, round to 2 decimal places. Then it's probably wants a fraction, brother. All right, let's look at number 12. 19 over 10 equals X over 12. So we're going to cross multiply. We're going to use our cross product property. So 19 times 12, 10 times X. And you'll see why I'm trying to write those out a little later. But right now, just it's not a bad habit to be in, but yes, I'll understand if you just do 19 times 12 on your own. What's 19 times 12? 228, thank you, ma'am. Equals 10x. Divide both sides by 10. So x equals 22.8. I mean, I'm not a fan of all the fractions or decimals, but they could exist. You want to do the one right below it since it's right there? Yeah. I can't wait till we get to 19. That's an honors only question, and it's awesome. I think I put one of those on your homework.
Okay, let's just skip to the honor.
All right, so cross multiply. Let's do one of these and we'll go to the honors one. Cross multiply. We probably need to do 2 of these for the video. Yeah, so when we cross multiply here, that's the reason I wanted you to get in the habit of writing out that cross product property. Because what happens is you guys try to go too fast and you forget that when this numerator, so when that 5 gets multiplied into that binomial, it's multiplied into both terms.
No, I don't.
So
What is
5x
quadratic equation?
plus 20 equals, what's 17 times 19? 324? 323? That's a fun number. Subtract 20 from both sides. It's an odd, like.
You get 3 of 3,
5x equals what?
3 of 3.
3 or 3?
That's not good.
Okay, I believe you. So divide both sides by 5. X equals, yeah, some kind of decimal. Someone hook me up. 60.6. Thank you.
Oh, it is a square root. Thank you. Not a square root.
Where is the square root?
Wait.
Oh, no.
Oh, yeah.
Let's look at number 18.
Oh, yeah.
We got double binomials, homie. Yeet, yeet.
Oh, dear. Oh, dear.
So we're going to cross multiply. Oh, that's a highlighter, dummy. So we cross multiply. 6 times 3x plus 3 equals 7 times x plus 16. Oh, yeah. Look at that beautiful thing. We got to double distribute. What? What? So 16 gets distributed. 7 gets distributed. So 6 times 3x gives me 18. 6 times 3 gives me 18. 7 times x gives me 7x. And somebody hooked me up with 7 times 16. 112? 112. Yeah. Solving for x, so you just want to get our x back, our x values isolated. So subtract 7x from both sides. So on that same step, I'm going to add 18 or subtract 18 from both sides because you guys are geniuses. You are. 18 minus 7 is 11.
That's not good.
112 minus 18. Hopefully it's 88. No? Dang it.
8.545.
94. Of course. Of course it's not nice and pretty for us. Divide both sides by 11. Sure. 94 over 11? Does it reduce? I don't think so. I don't think 94 over 11 will reduce. Nope. All right. So now we get to the beast.
goes fast.
You have to know the calculation.
So these 19 and 20 are honors questions because we're going to tap into your Algebra 1 experience. Because we may have to FOIL. We may have to factor.
You may have to use the quadratic equation.
You could use the quadratic equation, but I prefer factoring when factoring is possible. We can, but I was going to do 20. Why not?
Oh, 19.
I did factor 19 last class.
It's 4.
It's 140, so it's 14 and 10.
Wait, I got the right answer.
The answer is negative or positive 10 and negative 14, right?
Yeah,
Yeah, because those are your factors, weirdo.
it's 4x minus.
It's 5x minus 140, or 4x minus 140.
How do you factor?
What two numbers multiply to be negative 140 and add to be 4? Positive 14 and 10. Yikes.
I made that question a lot harder than
You really did. All right, so when we cross multiply here, we've got to think back to those beautiful algebra days. Oh my gosh, so I won't give you all leading coefficient, that's not 1. We're fixing to have some real fun.
It is really fun.
X minus 6. Oh, the leading coefficient's not 1. I'm going to show y'all the Berry method. I don't know if it's what they showed y'all. Probably shouldn't do that. It'll be okay. 7 times 6. So if you're on level, I would stop watching.
I've never wanted to be on level.
It's about to go down. So remember, we're going to FOIL. What does it mean to FOIL? What the? Yeah, it's when we multiply. So for the F, you multiply your first terms. So 2x times x. 2x squared. You multiply your outside terms. So 2x times negative 6 minus 12x. You multiply your inside terms. So 5 times x. 5x, and then you multiply your last term. So 5 times negative 6. Why would you do what? What's wrong with it? You are going to, oh yeah, y'all did slide and divide, didn't you? I'm going to show you a different way as well.
Slide and divide. It's not fun. It's not fun.
All right, so we're going to combine like terms in the middle. It's okay, guys. It's going to be okay. Your emotional support dogs are on their way. So 2x squared minus 7x minus 30 equals 42. When we solve a quadratic, it has to equal 0. So we're going to move our 42 to the other side. So we're going to subtract 42. How what? Well, what's 42 minus 42? It makes 0, right? So we got now our quadratic as it stands is 2x squared minus 7x minus 72 equals 0. Now, there's a couple of ways you can go from here. You can, nope, that's multiplying fraction or dividing by fractions. You can quadratic formula, if y'all talked about that before. You know, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a.
Yeah. Is that the song the guy like bum bum bum?
Yes.
That's so.
I am going to show you some. So in Algebra 2, you guys have talked about slide and divide. I'm going to show you something very similar. It's pretty much the same thing. It's called the Berry method. And it is very interesting. All right, so for the Berry method, we're going to multiply our first and last terms. So it starts off just like slide and divide. Multiply our first and last terms. What does that give me? 72 times 2x, which is?
70.
No, just the coefficient. So 72 times negative 144. So we need two numbers that multiply to be negative 144 and add to be negative 7. So what happens a lot of times is we're like, I have no stinking idea. So let's go through some of our factors. So, well, Peter, what two numbers multiply? Come on now. What two numbers do we know? Okay, we're not going to write that one because that's not going to help us. We got to start getting more towards the middle. So 12 goes in. How many times is 12 going to 144? 12 doesn't work, okay? Multiply to be negative 144, add to be negative 7. 8 and 18. So it's probably somewhere in the middle. 9 and 16. Does that give us 144? Right. So the question is, which one has to be negative? Which one has to be positive? Right. So our middle number is negative. That means the bigger value must be negative. All right. So these are our values we're going with, and we're going to go with a negative 16. Here's where it gets fun. Here's where the Berry method separates itself from slide and divide. We're going to take our two factors and we're going to create two fractions. Okay? We're going to create two fractions where our denominators are the two factors. What was our first one? Positive 9, right? And our second one was negative 16. Now we're going to use some not real math, but it's pretty cool. I'm listening. Watch this. Watch it. Wait for it. So 2x squared. We're going to say there's two of these, which isn't real math, but it'll work. So we're going to pop a 2x on top of both. Wait. Wait. I just said it's not real math, but we're going to write 2x on top of our numerator twice because there's two of them, which isn't really how math works, but we're going to go with it. The fraction on the left. Wait for it. The fraction on the left, can that fraction reduce? No. So read the fraction numerator to denominator. 2x plus 9. The fraction on the right, can it reduce? Reduce it, so that's, and the bottom becomes 8. Read the fraction, numerator, denominator. Because of Berry method.